Welcome to readmeproject.com. Now I am going to discuss about the accurate analysis of double weight codes with an arbitrary maximum cross correlation value for 2-chip power optical CDMA. Now I am going to explain the concept of this process. We are going to analyze the performance of double weight codes with the maximum cross correlation function. In OCDMA, same power, that is per bit duration, is used because of power restriction of some laser sources. The use of double weight optical codes was proposed to improve the quality of service. In fiber sensor systems, using optical codes for ultra-severe user identification purposes. In this, maximum cross correlation is fixed as 1 was exactly analyzed, but an approximation was only applied to the codes. Finally, we performed the energy efficiency for OCDMA systems. This is the flow diagram for accurate analysis of double weight codes with an arbitrary maximum cross correlation value for 2-chip power OCDMA. In this process, first we generate the input sequence, in this transmit the data. Then the next process is the prime code generation. In this, the modulation codes are partitioned into 3 number of groups. By using this, we can assign each user with one pattern and one of these 2 groups of individual double weight codes. It reduces the number of bits per symbol. Each user can use any one group of the double weight codes, whereas in existing system the user can use only one group of the weight codes. Then the next step is the cross correlation method. First we are going to fix the cross correlation. Before that, we know about the correlation. Correlation is the process of finding the similarity between 2 signals to recover the original signal. We can use any modulation codes to modulate the signal, but choosing the best code that results good separation of the signals between the 2 users. Separation is done by correlating the received signal and the modulation codes. If the signal matches the modulation code, then the correlation function will be high and the system can extract the signal. Correlation is a method of measuring the similarity of 2 waveforms as a function of a time lag applied to one of them. If the prime code, double weight code, has nothing in common with the signal, the cross correlation should be as close to 0 as possible. This is referred to as cross correlation. Then the next one is the CDMA method. OCDMA means optical CDMA. It does not need time and frequency management because all the users transmit using the whole bandwidth at the same time. Basic advantage is the way it handles a finite bandwidth among a large number of users. More users can transmit the same data over the same bandwidth. Then the final last before we find the BL analysis, that is the performance analysis. Why we find the performance analysis means then only we analyze the results. That is, get the performance for error probabilities contributed by interfering lower chip power code words to higher chip power code words. Then finally calculate the efficiency, that is energy efficiency for the whole process. Now I am going to explain the implementation work of this process. This is the MATLAB command window. These are the files used for this process. Main is the main program file. First click the main and right click, choose the run file option. Then the process is run. These are the results we find from this process. First, First, we generate the input sequence and split the first generate the input sequence and split the input sequence as the channel sequence and find the channel estimation. Then the next graph is the find the users. Here we use number of users. So first we find the symbols for every user. So find the graph, draw the graph between the time slot and the frequency slot. This graph is denoted as the symbol for user 1 and next one is the user 2 and the third one is user 3 and for the user 4. In this process, user 5. All of these plots denote where the user is placed between the time slot and the frequency slot. And the next one is the transmitted signal. First find the symbol users and the next is the how the signal is transmitted between the time slot and frequency slot. So find the transmitted signal for the 5 users. Then next one is the received matrix. So before that we transmit all the signals or data, then we receive the matrix format. Then the next one is the find the k users for the bit error probability graph. So this is the graph between the number of users and the bit error rate. This is the important simulation we get from our processor. This is in this only we find the error probabilities. For this we calculate the exact and approximate value, fix the exact and approximate value and find the various users. Then this is for the low-edge chip power codes, for finding the low-edge chip codes for different users. In this we change the lambda value and find the error probability. Then the final graph is the energy efficiency value. In the energy efficiency, number of iterations how the process are done and the graph is plotted between the iterations and the energy. From this we conclude that double weight codes with biased maximum cross correlation function has been formulated. Then the error probability curves of the higher chip power code words provide a performance lower bound. Thank you.